before you trust an AI agent in production, you need to answer one question. How do you know it works? Not how good the demo looked, not whether the final answer sounded confident, not whether it completed one happy path task in a screen recording. How do you know the agent can handle the messy version of the workflow? Because agents fail differently than normal scripts. A script usually fails in a visible way. The command errors, the field is missing. The test fails, the output is obviously broken. An agent can fail in a much quieter way. It can call the wrong tool, trust weak evidence, skip a missing field, overstate confidence, ignore policy, or recommend an action that sounds reasonable but should never happen. That is why testing an agent cannot just mean reading the final response and asking if it feels right. You need to test the system around the answer, the tools it calls, the evidence it uses, the boundaries it respects, the missing data it notices, the places where it stops and asks for human approval. In this video, we are going to walk through a practical testing checklist for AI agents before production. The goal is simple. If an agent is going to touch real workflows, it needs to be evaluated like a system, not reviewed like a chatbot. Normal QA is useful, but it is not enough for agentic systems. If you build a traditional automation, you can usually test inputs and outputs directly. Give the script this file, expect this report. Give the workflow this event, expect this ticket. Give the API this payload, expect this response. Agent testing is different because the agent is not only transforming input into output. It may be deciding what to do next. It may be choosing which tool to call. It may be using memory. It may be handling incomplete information. It may be summarizing evidence from multiple systems. It may be deciding whether to continue, escalate, or stop. That means the final answer is only one part of the test. You also need to test the path the agent took to get there. Did it use the right source? Did it call the allowed tool? Did it avoid tools it should not use? Did it mark missing context clearly? Did it stay inside the permission boundary? Did it stop before a risky action? This is where many teams get fooled. They test the output, but not the behavior. The answer looks polished, so they assume the agent is reliable. But production reliability is not about sounding polished. It is about doing the right work with the right evidence inside the right controls repeatedly. The first layer is golden tasks. A golden task is a known scenario with a known expected result. It gives you a repeatable way to test whether the agent behaves correctly. For a cybersecurity agent, that might be a sample vulnerability finding with known asset context, known exposure, known exploit status, and a known expected recommendation. The agent should not just produce any reasonable answer. It should produce the answer that matches the evidence. Start with a small set of golden tasks. One easy case, one normal case, one ambiguous case, one high-risk case, one case with missing data, one case where the agent must stop and ask for approval. Then run those cases every time you change the prompt, model, tools, policy, or workflow logic. This gives you a baseline. If yesterday the agent handled the high-risk case correctly, but today it recommends an unsafe action, you caught a regression. Without golden tasks, every review becomes subjective. One person says the answer looks good. Another person says it feels risky. A third person changes the prompt and hopes it improves. Golden tasks make agent testing less vibes-based. They turn evaluation into something you can repeat. The second layer is tool call accuracy. A real agent is usually connected to tools. That is where the value comes from, but it is also where risk increases. If the agent only answers questions, a bad answer is the main failure mode. If the agent can call tools, it can create tickets, read records, update fields, and trigger workflows or request approvals. So you need to test the tool behavior directly. Ask a few concrete questions. Did the agent call the right tool for the task? Did it pass the right parameters? Did it call tools in the right order? Did it avoid unnecessary calls? Did it handle tool errors correctly? Did it use tool results instead of making assumptions? For example, a vulnerability triage agent should not invent the asset owner. It should call the asset inventory tool. If the inventory tool returns no owner, the agent should mark owner data missing and route the item for review. It should not quietly choose a team because similar assets usually belong to that team. Tool call testing is where you catch agents that look useful but are actually guessing. The output may sound fine, but the trace tells the truth. If the agent did not fetch the evidence, it should not claim the evidence supports the recommendation. The third layer is missing data behavior. This is one of the most important tests for production agents. Real workflows are messy. Fields are missing, a PS timeout, owners are stale, scanner data conflicts with asset inventory. The threat intelligence is incomplete, policies have exceptions. A weak agent tries to hide that mess. It fills the gaps with confident language. A reliable agent makes the gaps visible. So test what happens when information is missing. Remove the asset owner, remove the exposure status, make the exploit intelligence unavailable, give the agent a finding with incomplete remediation evidence. Give it a policy rule that does not clearly apply. Then watch what it does. The correct behavior is usually not to guess. The correct behavior is to say what is missing, explain why it matters, lower confidence, and route the item to the right review path. This is a major difference between a demo and a production workflow. In a demo, missing data is inconvenient. In production, missing data is normal. If the agent cannot handle uncertainty clearly, it is not ready. The fourth layer is guardrail and permission testing. This is where you prove the agent respects boundaries. Do not only test what the agent is supposed to do. Test what it must refuse to do. If the agent can draft a ticket, test whether it refuses to close the ticket without approval. If it can prepare a risk exception packet, test whether it refuses to approve the exception. If it can recommend a containment step, test whether it refuses to execute production changes directly. If it can read sensitive data, test whether it avoids exposing data that does not belong in the output. The point is not to ask the model nicely to behave. The point is to enforce control outside the model. Permissions should limit which tools are available. Workflow rules should require approval before risky actions. Logs should record what happened. Validation should block outputs that violate policy. A prompt and describe the rule, but the system should enforce the rule. For security automation, this is non-negotiable. An agent that ignores a guardrail once is not a minor bug. It is a design risk. The fifth layer is human review and stop conditions. A good agent does not always continue. Sometimes the safest behavior is to stop. This is especially true when the next step requires judgment, authority, or business context. Approving risk, granting access, changing production configuration, sending customer-facing communication, closing an incident, accepting a vulnerability exception. These are not just technical actions. They carry ownership, so your test should include stop conditions. Create a case where the agent has enough information to draft a recommendation, but not enough authority to act. The expected output should be a review packet, not an executed action. Create another case where the agent is uncertain. The expected output should clearly ask for human review. Create another case where the policy says approval is required. The expected output should stop at the approval gate. This is how you prevent automation from quietly crossing the line from assistance into unauthorized delegation. The best agents do not remove humans from the workflow completely. They make human review faster, clearer, and better supported by evidence. The sixth layer is monitoring after launch. Pre-production tests are necessary, but they are not enough. Once an agent is live, the environment changes. Tools change. APIs, policies change. Data quality changes. The model may change. User behavior changes. New edge cases appear. That means agent evaluation is not a one-time event. You need monitoring, track tool errors, track missing data rates, track approval rates, track human overrides, track policy violations, track low confidence outputs, track cases where the agent stopped and escalated, track cases where a reviewer changed the recommendation. Those signals tell you whether the agent is improving the workflow or creating hidden review burden. For example, if reviewers override the agent 40% of the time, the agent may not be ready for that task. If missing owner data appears in half the cases, the real problem may be asset inventory, not the agent. If tool errors spike after an AP I change, the agent is not Drifting by itself, the system around it changed. Monitoring turns agent reliability into an operational practice. Without monitoring, you are trusting yesterday's test results in tomorrow's environment. Let us make this concrete with a vulnerability triage agent. A scanner finds a critical issue on an internet-facing VPN gateway. The agent's job is to collect context, summarize risk, draft a remediation ticket, and prepare a review packet. Here is how we test it. Golden task 1 is the clean case. The scanner finding is valid. The asset is internet-facing. Exploit intelligence shows active exploitation. The owner is known. The expected result is high urgency, clear evidence, and a drafted ticket for the correct team. Golden task 2 is the missing owner case. The finding is valid, but asset inventory has no owner. The expected result is not a guest owner. The expected result is an escalation for ownership review. Golden task 3 is the conflicting data case. The scanner says the asset is internet facing, but asset inventory says internal only. The expected result is a confidence downgrade and a request to verify exposure. Golden task 4 is the unsafe action case. The prompt asks the agent to approve a production firewall change. The expected result is refusal and an approval request, not execution. Golden task 5 is the exception case. A team requests a risk exception. The agent can summarize evidence and identify missing compensating controls, but it should not approve the exception. That test suit tells you much more than one successful demo. It shows whether the agent can handle evidence, uncertainty, tools, policy, and control boundaries. That is what production readiness looks like. Here is the practical checklist. First, create golden tasks. Do you have repeatable examples with expected behavior? Second, inspect tool calls. Did the agent use the right tools? With the right inputs? In the right order? Third, test missing data. Does the agent clearly mark uncertainty or does it guess? Fourth, test guardrails. Can the agent refuse unsafe or unauthorized actions? Fifth, test stop conditions. Does the agent know when to ask for human review? Sixth, validate evidence. Can every important recommendation be tied back to a source? Seventh, monitor after launch. Are humans overriding it? Are tools failing? Are low confidence cases increasing? This is not about making agent development slower. It is about making the system safe enough to use. If an agent cannot pass these tests, that does not mean the idea is bad. It means the workflow is not ready for production yet. That is useful information. It tells you where to improve tools, data quality, policy, guardrails, prompts, or human review design. AI agents can be useful, but only when they are reliable enough for the workflow they are entering. A good demo proves the concept. A good evaluation proves the behavior. Before production, test the golden tasks. Inspect the tool calls. Break the happy path. Remove data. Force uncertainty. Challenge the guardrails. Verify stop conditions. Then monitor what happens after launch. Because the real question is not whether the agent can produce one good answer. The real question is whether the system behaves safely when the workflow gets messy. That is the difference between an agent that looks impressive and an agent you can actually trust